Let's get right into it, brothers. Today, we're walking through the exact standard operating procedure for Incident 16. This is the explainer you're going to need when your nitrate and nitrate levels suddenly spike in your biological wastewater treatment system. Look, I know you're out there managing these massive plants. And man, when those numbers start climbing, the pressure is absolutely on. So we're going to break down this SOP step by step so you know exactly how to handle it.
We are going to treat your system just like a patient today. We'll be hitting 5 critical areas: anatomy and baseline, symptoms, diagnosis, treatment, and finally, recovery. We'll start by looking at what healthy actually looks like, and then move all the way through getting your plant back into full compliance.
Okay, Section 1, Anatomy and Baseline. Understanding nitrification and denitrification. You already know your biological nitrogen removal relies on a super delicate balance. You've got your aerobic bugs that absolutely need air for nitrification, and your anoxic bugs that need zero oxygen for denitrification. If either group is unhappy, well, the whole system fails.
I want you to literally burn these baseline vitals right into your brain, brothers. Think of this as your holy grail for a healthy plant. Your anoxic dissolved oxygen, that must be tightly controlled at or below 0.2 milligrams per liter. Your carbon to nitrogen food ratio needs to be sitting at least 4 to 1. And your sludge age, your MCRT, that should be in the sweet spot of 6 to 10 days. Also, your internal recycle flow has got to be 2 to 4 times your influent flow, and keep that pH locked in tight between 7.0 and 7.5. Because look, if your DO creeps up above 0.2 or your carbon food source drops out, the whole process breaks down.
Moving on to Section 2, Symptoms and Risks. Spotting as sick system. You know what's really interesting here? It's how your plant visually tells you it's failing long before those environmental finds even hit. You don't always need a lab result to know something's wrong. Your basins will physically show you a sick system.
You've got to pay close attention to these warning signs. Obviously, if your total nitrogen exceeds your limits, or if your nitrite spikes over 1 milligram per liter, which by the way is highly toxic to downstream fish, those are massive red flags. But what about physically? Well, if you start seeing cloudy, light blue water, or if you catch a really foul, unpleasant stench, or, worst of all, if you see sludge floating with trapped nitrogen gas bubbles out in your secondary clarifier, your denitrification process is severely interrupted.
All right, Section 3, the 8-step root diagnosis, finding the broken link. Look, when you see those symptoms, panic just isn't an option. And you definitely can't just guess what's wrong. You need to follow this strict 8-step diagnostic checklist to find the exact root cause. Guessing just leads to the wrong chemical dosing, and that's just going to make the patient sicker.
Let's walk through the first 4 steps. First up, you pull your samples at the outlets to check your nitrogen species, your nitrate, nitrite, and TKN. Second, check your influent food ratio. Ask yourself, is it dropping below that 4 to 1 mark? Third, grab your multi-point meter. You want to make absolutely sure oxygen isn't bleeding into your anoxic zone, so you're checking for anything over 0.2. And fourth, verify your internal recycle flow on your meters to ensure it's actually pushing 2 to 4 times your influent volume.
Moving right along to the final 4 steps. Step 5, verify your sludge age isn't drifting out of that 6 to 10 day sweet spot. If it's too young or too old, those bugs just can't do their job. Step 6, physically get out there and inspect your mechanical pumps for air leaks and check your mixers. Step 7, review your flow data logs for the past 7 days. You're looking for any sudden hydraulic shock loads or maybe illegal dumps. And finally, Step 8, if you have the lab capacity for it, run PCR or NAR enzyme tests on your microbiologist.
Okay, Section 4, Treatment Plan. Triage and corrective action. Now it's time to treat the patient based on urgency. We're moving from immediate triage all the way to long-term immunity. Once you've completed that diagnosis, you have to act, and act decisively.
We're going to break your response down into exactly what you need to do on a very strict timeline. First, we have the 0 to 24-hour window, which covers your emergency fixes and dosing to basically stop the bleeding. Then, we look at the 1 to 7 day window. That's all about short-term stabilization and equipment repair. And finally, we look at the long term, which focuses entirely on facility upgrades and permanent prevention.
So in those first 24 hours, it is all hands on deck. You need to crank up that internal recycle or IR to maximum, around 3 to 4 times flow. At the same time, you've got to cut back on aeration at the end of your aerobic zone to stop any oxygen carryover. You also need to immediately manually dose an external carbon source, something like methanol or glycerol, to feed those starving bacteria. And lastly, adjust your sludge wasting right away depending on what you found in your MCRD diagnosis.
Then, over the next 1 to 7 days, brothers, the panic subsides and the real work begins. Now you optimize your recycle based on your actual nitrate loads, rather than just maxing it out. You switch that emergency carbon dosing over to automatic control. You got to get the wrenches out and fix any broken pump seals that might be letting air in, give your mixers a good clean, and gently adjust that pH right back into the 7.0 to 7.5 range using sodium bicarbonate or hydrochloric acid.
Now, to secure the long-term fix, because trust me, you do not want to fight this exact same battle again next month, prevention means capital improvements. We're talking installing baffles to prevent short-circuiting, maybe upgrading to an equalization tank to handle those sudden shock loads, and getting continuous online NOx, DO, and COD sensors so you aren't just flying blind. It also means consistent training for you and your operators on nutrient balancing.
Which brings us to Section 5, Recovery, monitoring the vitals. Let's move into this recovery phase and see how all this builds into a stable, compliant system over a 7-day monitoring period. Because remember, just because the alarms have stopped doesn't mean the patient is totally out of the woods yet.
You absolutely must track these vitals rigorously during that 7-day recovery. I'm talking daily checks on your total nitrogen, your nitrate, your COD ratio, and your MCRT. But look at that anoxic DO row right there. You need to be hitting that check 4 to 6 times a day to ensure it stays at or below 0.2 milligrams per liter. That tight DO control, that is the only way you're going to ensure that toxic nitrate stays below 1 milligram per liter.
So, when can you finally take a breath and relax? Well, you can officially declare the incident resolved when your nitrate stays strictly under 1 milligram per liter for 3 days straight. Your total nitrogen is fully back in compliance with your discharge permits, and your overall denitrification efficiency is restored to at least 85%. That's when you know you've won.
Once the plant is healthy again, the paperwork begins. Don't forget to formally log the verified root cause. You also need to update your carbon dosing reference tables based on what you just learned during the crisis, update your equipment maintenance schedules, and honestly, most importantly, get your shift team together within 48 hours for a full team debrief. Everyone needs to learn from this event.
I want to leave you guys with a summary quote straight from the standard operating procedure. It says, solving this requires sufficient carbon, strict DO control, optimal recycle, and healthy sludge. Remember, this whole process is just an interconnected machine. Feed them carbon, starve them of oxygen with strict DO control, keep that recycle flowing optimally, and manage your sludge age. If one piece fails, they literally all fail. Operating a biological treatment plant is a massive responsibility, brothers. So I'll leave you with this question to think about on your very next shift. A healthy plant requires constant vigilance, so are your online sensors freshly calibrated? And are your carbon sources ready for tomorrow's unpredictable shock load? Stay vigilant out there. Keep those basins balanced, and I'll catch you on the next explainer.